Hello, my name is René Nielsen, working with SPX FLOW. Thank you for joining us today, where we are to discuss ultra-high temperature systems. A little about myself. I've been working in manufacturing the first 15 years of my professional career before I moved into process engineering. And for my last 12 years, I've been working out of Denmark in all of the concepts, design, and supply of various UHT systems, mainly looking into the liquid industry, where we actually can say that we are working with various applications for aseptic technologies and for UHT systems. The goal today is for everybody to be able to take away some new information about high temperature systems, and to learn how we can help and how we can support you in your role of the different applications that you actually have. A few housekeeping notes before we get started. As an audience member, you will not have audio or video capabilities, so please use the Q&A feature to submit any questions throughout the presentation, and I will answer as many as possible in the end. Also, there will be my contact information, and I will be happy if you would give some feedback on this, but also send additional questions to it. When it is that we are talking about SPX FLOW, we are very dedicated throughout the innovation and sustainability on the solutions that we actually have. It means that we work a lot on our UHT systems to be as environmental friendly as possible. I know it's not always easy, but we are really trying hard to see how can we actually do it. I will come into some of the points that we have actually made improvements to our systems. So today I can actually say that we are number one of the pack out there in the playing field. The agenda, how we are trusted globally for UHT, a little about market trends and opportunities, a little about what is it actually that our systems and solutions that we actually have and that we can offer to you as our customers, a little on the case study of a customer that we actually have who has been very dedicated towards supporting us in this, and then a little related to the pilot plant and service information. You can say that what is it actually that SPX FLOW we are doing? Well, SPX FLOW is an American company. It has been in US for always. I'm located in Denmark, but SPX FLOW is an American company. And we have an American offices, American manufacturing. So it means that we have a dedicated team that is there to help you in US. You can say we have been on the market for a very, very long time. You can say plate heat exchangers, tubular heat exchangers, commercial UHT systems, and also direct UHTs. It's something that we have launched over the last more than 100 years. So it is things that we are actually there. And you can say that the funny thing is actually that we launched the UHT system before there was an aseptic filling machine. So that's a little curiosity that actually is in there. You can say one of the latest things that we have introduced is actually on the InfusionPlus. The InfusionPlus is where we go in and we make high temperature treatment of a fresh product. So it's an ESL process that we actually can go in and do, and I will come back to that. When we are talking about market trends and opportunities, it's mainly within the lactose-free area, but also on the plant-based applications, where we actually are spending a lot of time on when it comes to UHT process. One of the things that is for the sustainability of these type of products is that it can be that it's actually a relatively newer products, but on the other hand, they also want to be manufactured sustainability. We have a growth, especially in the lactose-free and the plant-based products. And that growth we can also feel and we are part of. And we are actually supporting that by the way that we are looking into the system side. You can say we have some areas where we actually are working quite heavily, and that's on reducing the utility consumptions. For instance, introducing insulation on the chambers that you actually have on the direct UHT systems, and thereby reducing the energy coming out of the chamber by around 90%. It sounds a lot. It is also quite a lot, but it's not always that when you look only on the pure money and the pure payback time, that is actually enough for you actually to go into it, but it's a possibility. And then there is other options that we actually can put into it that is there to support the growth that you actually are planning to go into in the playing field. For the lactose-free processing, you can go in and say that what is actually playing there, that's the taste, stability, color, flavor, viscosity, and all the other parameters that it is that you're actually looking into. You can say when we are talking about lactose-free, you have the raw material, you have the key to go into this, but you want to preserve that the best way possible. And that can sometimes be a challenge when it is that you are manufacturing the lactose-free, where you actually are removing the lactose or converting the lactose into other types of sugars, and thereby making it more vulnerable for the heat treatment that you actually want to add into it for it to have a longer shelf life. So it means that we need to look into how can we actually preserve the raw materials and reduce the processing cost that you actually have into it. And at the same time, we want to have a high flexibility on the different systems that we have. It means that it can be that you really want to manufacture one type of product, but you have other products that you also want to manufacture. So we want to make like a system where you still can make some of the innovative products that you are manufacturing, but you still want to maintain the base production. So we have to make it flexible, and we need to make it so robust that it actually can run a lot of different products that you actually have. And that's really where it sometimes can be quite difficult to describe what it is that we are putting into the systems, but that's where the key is for SPX to be. For the plant-based products, you can say you have a lot of challenges as it is a relatively new product. That new product that you actually have there has only been existing for the last 20, 25 years. We know we built the first soy plant 50 years ago. And that was actually when it was in the green area, really starting point of these plant-based products. But it's coming more and more, and it's getting more into a commodity now. So we have been part of the development from the beginning. But still, there are some challenges when it is that we are talking about these plant-based products. Some of the challenges is that you have the raw materials. It's a designer product. It's a product where not two recipes are the same, even though you say, yeah, it's an oat milk, yeah, but it's manufactured at two different manufacturers. So it's two different products. And that creates some challenges when it is that we look into say, okay, yeah, but it's only oat milk. Yes, but it's different from manufacturer to manufacturer. So that's why we sometimes get into to ask a lot of questions. And even though we know oat, we still need to do a lot of things in order for the plants actually to run better on these type of products. What is it actually that we can offer to the market of these things? Well, you can say we supply a wide variety of UHT systems. When we look into the different UHT systems, you can say that we split them up into two categories, into direct UHTs, that is where we use direct steam in connection with the product to heat up. And then we have indirect UHTs, that is where we have heat transferred. It means that there is a transfer of water into the product where we actually can heat up with by this. The direct, you need to have steam for heating up. It goes very fast. You can say typically it goes when you are talking about infusion. You have product that goes into steam. So you have a steam-filled chamber where you're putting in product. And that heating time is around 0.2 seconds for to get up from the preheating temperature to the final heating temperature. And then you have injection system where you inject steam into the product. That's a little more common, but it's also takes longer time. And there's a small changes on how the performance of the product is when you're doing injection systems or if you're using infusion systems. I will come a little back to that. But you can say both of them is actually heating up quite fast. Whereas compared to the indirect, where you have using a heating media to heat up with, there we split them up into tubular, plate, and scrape surface heat exchangers. Where you can say tubular and plates, they are very common to use within the liquid industry. The scrape surface heat exchangers, they are a more niche product used for very high viscosity, for products with particulates, for specialty products. So it makes it a little more complicated to use and more expensive than to use on the others. So when you are splitting it up like this, it's actually quite easy to see what is the difference between the two different systems if you're using a direct or if you're using an indirect. I will go into a little more details on what is actually the differences of these, because we need to know that when it is that we want to design the type of product that we want to go up with in the end. Putting it up in a little different way, you can say we have the direct heatings, where you have the infusion UHT. That's the standard infusion that we actually use for a lot of different products. Then we have some variants. The instant infusion is where we can go with very, very high total solid, all the way up to 55-60% total solid. We can do UHT treatment of your products on this, and also with very high fouling products. That is when we can go into this. And then we have the latest in the stage, and that's the InfusionPlus. That's where we go very high in temperature with that extreme short holding time. It means that we heat up very fast. We keep it for very, very short, and then we cool it down in a flash cooler afterwards. So the total heat exposed into the product is very little, so the chemical damage to the product is minimal. And that's how we can actually assure that you keep a product that tastes very fresh and that has the abilities, and you preserve the vitamins and the minerals that you have in milk, and you don't damage it too much. Then you have the injection system. That is where we can go in and we can do a lot of UHTs. We can also do ESL products with the injection, but the chemical damage is a little higher than what you actually can do on the infusion. And then we have the indirects. We also make a lot of different systems in combination of all of these. It means that if you have some products where you actually need to run on a tubular UHT, but you also at the same time want to have some products that will benefit of an infusion system, then we can do a combination of this. So we can do a combination of a tubular for the tubular part of it, and then the infusion part, for you will run the products that is actually going into the infusion. And together with that, and on our pilot plants, that will most of the time be a multi-purpose plant, where you actually can do a lot of different technologies from that, where you can test the different products. Actually, on the pilot plants, we have a scalable pilot plant. It means that when you run on our pilot plant, you can scale it up to the commercial plant with a minimum interference with changes to the recipes before you run it there. Let's go in and see a little on the injection. The injection principles is where we actually go in and we say that we have a balance tank system, we have a feed pump, we have a plate heat exchanger or a tubular heat exchanger for preheating. We want to preheat up to a level as high as possible, because when we are using a plate heat exchanger or tubular heat exchanger for preheating, then we can a lot easier make some energy recovery on these parts of it. Then we go into the injector, where we inject steam into the product. We have a holding tube after the injector. Then a flash chamber, where we flash off the water that we have added in the injector. We add steam through the injector to heat up the product. That steam will turn into condensate when we heat up the product, and thereby be water, and that water we take off in the flash chamber. Then we have a centrifugal pump and a homogenizer. We always use downstream homogenizer when we are talking about direct UHTs, because when we are having these direct UHTs where we heat up fast, we flash cool very fast, then there can be some protein agglomerations that can actually occur on products. We destroy these agglomerations with the homogenizer. Then we go back to the plate heat exchanger or tubular heat exchanger for first energy recovery cooling, and then if necessary, ice water cooling afterwards, or glycol. And then we can go to an aseptic tank and to a filling machine. This is a basic principle, a direct UHT system. Some of the key things that is actually into it is that we go in and we look in the injector. You can say that's really where we separate us from the others when it is that we are talking about injector systems. It is that we have our injector, and that injector we have actually put in quite a lot of work in order to have it to be as optimum as possible. It is built up where you actually have steam going in and you have product going in, and then you have a chamber where you actually have the mixed zone of steam and product. That mixed zone, you can change the size of that mixed zone depending on what type of products you're actually manufacturing. It means that you can optimize it for some products and thereby reducing the noise that actually comes out of the injector. That's typically one of the biggest pain points there is with an injector system, is it's more noisy than when it is that we have for some of the other UHT systems. Then we was a little on the injector. Let's take the infusion. When we are talking about the infusion, you can say that this is really where we are very good on the market. This is where we can say that we have the biggest benefits. And that's where we are being recognized by our customers of having the best product that is actually there. Just a small picture of a system, of a complete infusion system where you actually have the main skid, you have a preheater and cooler, you have a homogenizer, and over here you have the aseptic tank system. You can say this is actually built extremely compact and very friendly on the maintenance side, trying to obtain as little floor space as possible, but still to be able to optimize it in a good way. So that's why when we are building these systems, when we are optimizing the systems, then we actually have our service people to be part of it, to help us to see how can we actually do service per a plant that is actually being installed at one of our customer sites. It's very important that you actually can do the service and you can actually do it so the best way possible, because if it is easy to do maintenance on, then it's also more likely that the people will love to work on the plant, and therefore it will be run in a lot better state if it is that we can do both that, the maintenance, but still build it up logically. If we look on the infusion part, it's close to the same as the injector, but where we actually have the balance tank, feed pump, and the preheater, then we actually have the infusion chamber, where we have product going into the infusion chamber, where we had the injector before. Now you have the infusion chamber, and you have an empty chamber where you actually pump it into the holding tube and into the flash vessel. After flash vessel, homogenizer, then plate heat exchanger, tubular heat exchanger for heating, for cooling, and then into the aseptic tank, into the filling machine. This is actually where the magic happens when it comes to infusion. If we should look a little more close on the infusion chamber, we have the chamber. We have the product that is actually coming in through a distributor nozzle in the top, where we are distributing the product into small strings, droplets, coming into the infusion chamber, where there is a large surface so the steam can be absorbed by the product and thereby heated up. During this, there will be steam around in here. This steam will be at 0.5 to 1 degree higher than what is actually the desired temperature of this. It means that there's very, very little temperature difference between the product and the steam that you actually have in the infusion chamber. So by little temperature difference, it means that the delta T is little, so the damage to the product will be minimum. If you have a very high delta T, then there's a risk that more product will actually be damaged. So when the product comes in and being heated up, if it is a product that contains a lot of air, then we can take that air out because it will be released from the product when it's heated. So it don't interfere with the heating process. We always have an empty chamber because we don't want to have any products to stay in the chamber. We want to keep it up there as short time as possible at the high temperature. When we are looking into the infusion part, we are seeing we want to heat up as fast as possible. We want to do it as energy efficient as possible. It means that we are trying to build in a lot of features into the system where we can actually save energy on this. It means that the condensers that we actually have in there, we have some features where we can save 10-12% energy. On the sterilization, when we are sterilizing the plants, we have built in some features where we can actually save a lot of the sterilization energy. We have built in advanced software that is looking into say, okay, when should we actually do CAP and sterilization of the plants? Then there's insulation of the system. We can actually do some insulation of the chambers where we can actually do some saving of this. And this is actually what we are working with when it comes to the NPDs. There are three main areas: utility consumption, production time, and operational efficiency. That's the areas that we are focusing on when it's coming to these things. And that's really where we think that we can make a difference on when it is that we have these systems. When it is that we are looking into the infusion systems, we can build them on a variety of flow rate. The largest one we have built is up to 220 gallons per minute. And we can go all the way up to 315, 320 Fahrenheit on the temperature when it is that we are doing that. We can do that with a very, very short holding time. It means that when it is that we are doing this to preserve the product as good as possible, when it is that we are talking about ESL products, for instance. That's why we can go all the way down to a holding time of very, very short when it is there. And when I say very, very short, it is actually the shortest possible that it is there. And that's actually the time that the product is exposed to the heat. I'm not talking about legal holding time, because of course that needs to be in place, but we can actually do it as short as possible when it comes to that. When it comes to expose the product to the heat, we need to preserve all the nutrients that is actually in there. Let's look at some of the advanced features that we actually have into the system. Some of the advanced features is actually that we can mount a camera in there, so we can actually see what is operating, what is the operating conditions inside the infusion chamber. When we are doing this, it is to help the operator to operate the plant. And that way we can actually see when he looks sitting with the control room and looking into the chamber, he can actually see what is happening in the distributor nozzle. He can see the two steam inlets. He can see the light source. And then he can see that the product is actually going in and it is manufacturing in the correct way that is actually in there. We all normally also have a camera mounted downwards inside the infusion vessel. That way we can see that the plant is always empty. The infusion chamber is empty. There's nothing in there. And that is actually very, very important that we actually do it like this, so we don't have a buildup of the product. We can see that the center that the product is hitting the center. So everything is running as it is, and it's running very smooth and efficient. Looking a little into the automation system, we have a way where we can actually go in and do online calculation of the F0 value and the B star value that we actually have there. And we can use this as a divert value on this, depending a little on the products that you're actually manufacturing, if it is a possibility. But it is a thing that we can actually build into it, so you can differentiate the B star value, F0 value, for all of the different products that you actually manufacture. We also have where we can go in and calculate the holding time always. It means that we can see on what is actually the temperature that you are running, what is the flow rate that you are having. And that way we can actually do the combination of the two and how we actually are running in the plant. At the same time, we have built in systems where we can actually go in and say that the plant is in balance. It means that when you have a system where you are adding steam into the product and you are using vacuum to take off the water afterwards, then there can come an unbalance into the system where you can actually have a risk of concentrating the product or diluting the product. We have built in a system where we always look at the different parameters that is happening in there, so we can actually see what is the total solid of the product when it comes out of the system. Is it more or less the same as it is when it goes into the system? Pure based on calculations. It's not measured, it's only calculated, this system. But it's actually giving a very good indication of how is the plant running and helping the operator to operate the plant a lot better. This is one of the things that we have built in, where we actually can go in and say that we can save some energy. This is a non-aseptic cooler. It's used when you are doing sterilization and you are doing CIP of the plant in order to recirculate hot water to sterilize it. You are cooling the water down before it goes to the balance tank, and then you heat up again. And then you do that recirculation for around 20 minutes to sterilize it. Typically way of doing it is that you have a tower water non-aseptic cooler where you cool down the water before it goes to the ballast tank. We have put in a second set of tubular heat exchangers in order to recover some energy. We recover the energy into the hot water section, so we take the first shot of the cooling with these before we take the last set with the tower water. Then when we have, after the ballast tank, we heat up again with the water that we actually used for cooling. That system saves up to 2/3 of the energy you're using during sterilization. When it is that you have sterilized the plant and you are ready for production, then it's not uncommon for the plant just to wait and starting to recirculate with water, waiting for the production to start up. It can stand there for quite some time. We have some customers who have been leaving it there for quite some time. And in order to save some energy, then we have introduced the hibernation mode. We did that for some time ago. When it actually has started to recirculate for 30 minutes at full capacity, after sterilization and waiting for the downstream equipment to be ready and the upstream equipment to be ready, then we shut down the system automatically to 50%, maintaining sterility, and thereby waiting for the plants upstream and downstream to be ready, but saving a lot of energy because we are lowering capacity on the plant. Maintaining sterility is priority number one. So it just starts to recirculate there and saving a lot of energy. And then when the plant is ready for starting production, the operator says start production, and then it automatically ramp up, start the ice water again, and then it's ready to production. This is one of the things that can easily be retrofitted into systems in order to build them. We can also, in the condensers, when it is that we are using the flash chamber, the flash chamber is cooling down the product and also taking some water out at the same time. That water contains some energy. That energy we can reuse in the UHT system. We can reuse it in the hot water section and use it for preheating. That way we can actually save energy in the preheating from the condensers and thereby save up to 12% of the energy used in the preheating section. It's not much, but it's enough that it actually helps you on these savings of the energy. We can also put them in, and then we can use the energy externally out of the UHT system. Most of the times we actually can use it internally when it is. And that means that whenever you're running the plant, you will be running also these energy saving features. When it is that you have a system and you're actually having the flash chamber where you are taking off some vapor, that vapor, when you are running through the condensers, it's turning into liquid again. That liquid we can reuse for something. It contains some particulates of product, but you can easily put them into a tank, use a membrane system to clean that water up and use it for some purposes afterwards. You can also use it for surface cleaning, for floor cleaning, for other areas where you actually need some water, where the cleanliness of the water is not as well. It's approximately 14% of the plant capacity that actually goes through there that we can recover in this way. It's a free way of getting some energy or some water that still has around 60 degrees C, so it actually contains some energy. When we are talking about Infusion, the latest one that we introduced was InfusionPlus. That is where we have commercial sterile product, but with the chemical damage to the product as low pasteurized milk. It means that we can actually manufacture an ESL product that has a very long shelf life, but the taste of the product is the same as low pasteurized milk. We introduced it in 2011. We have around 45 plants globally. We got a patent in US in 24. So you can say that this is an area where we actually believe that it's something that could be very useful on the American market that is highly dominant by ESL products. If we look into say, okay, we have the starting point of the product, we go at a low temperature, then we have a preheating, then we heat up very high, up to 300, 320 Fahrenheit. We do that in very short time, 0.2 seconds. We keep it there for the high temperature for as low as down to 0.09 seconds. And then we flash cool it. We homogenize it, and then we go through the plate heat exchanger, tubular heat exchanger for cooling again. But doing this with the flexibility that we can actually say, okay, one day we can do InfusionPlus, but the next day we can actually do a standard product, a standard UHT product. It means that you can introduce it. You can see that it's actually gaining pace in the market, but at the same time, you can use the system for your normal products that you're actually manufacturing. By building these systems, we actually are looking into the ISO diagram that we actually have there, where we look into the combination of temperature and time when we say that how has the combination been with the holding time and the temperature that we actually are exposing to the different products that we have. And there we can actually see we have the InfusionPlus is actually above the chart when it is that we are having it there. That was before when this chart was made. The InfusionPlus was just a dream that somebody had, and it was actually not developed yet. So you can say it actually blows off what it is that we are doing it. But when we are looking at this ISO line diagram, we can see there is a correlation between the sterility and the chemical damage that we actually have. It means that we can do a calculation of what is the theoretical damage to the product that will actually happen at a certain temperature time combination that is actually going into it. And if we look into the InfusionPlus, we can go in and see that with a combination of 315 Fahrenheit and 0.09 seconds, we actually have a commercial sterile product. We can go in and say that we have a B star value 1.44 and an F0 value of 7.16. And then we can go in and say, okay, by this combination, what damage will actually happen to the product when it is that we see. And we can see that it's actually very equivalent to the low pasteurized product that is actually there. You see the whey protein denaturation is very little. It's only less than 10% that's actually denaturated. The lactulose will actually be less than 10%. And we have a very, very little color change that actually goes into it. And all of this is actually more or less the same that would actually happen if you have a low pasteurized milk. But remember, this one here actually has a long shelf life. Fresh, cold chain, we would have 3, 4, 5 month shelf life. But it is only for fresh and for cold chain, not for ambient storage. Because at the same time, when we go high temperatures, very short holding time, we have very, very little inactivation of the enzymatic activities that is actually happening there. And that's why we can't do it ambient, even though it is an aseptic product. If we go in and look on comparing the different technologies that we actually have, then at the same time, we can also go in and see what is actually the B star value of the product. Here we combine all 4 technologies with on the B star value where it is the same. Here we are not looking at the legal holding time. Here we are looking at the time the product is exposed to the temperature. It means that this one here, for a legal point of view, would not be aseptic, but when you are looking, including the heating time, the holding time, and the cooling time, then you actually have an aseptic product. It means that you have a B star value of 1.29. Because when we are looking into this, we are looking into the taste of the product and how is the product, not on the legal side of the pasteurization effect of it, but on the product and the taste of the product. So if we compare InfusionPlus, we can, with a not standard infusion and with injection, we can see that we actually have high temperature equal high spore kill, the vitamin B1 destruction, very little because of the high temperature short holding time, and the whey protein denaturation. We also can see that it's very, very little compared to infusion, but especially also compared to injection. By the means of tubular, we are always denaturating most of the whey proteins, or not to say all of it, because that's actually the nature of it. And many times we have a protein stabilization holding tube that is actually making sure that we have all whey proteins denaturated. A little case story. When we look into this, we have a plant that actually we started 7-8 years ago when we supplied the first one, where we did a lot of testing with the InfusionPlus technology. And this is actually gaining a new market where they are, you can say they have set a new standard for products. And really the market share that they have gained on this and how they have actually pushed the others to go into a different market on these things, that is really impressive on this. To say that this is actually a possibility in other areas also of the world when it is that we are doing it. When we look into say, okay, we can help you on designing these type of products, because we have various pilot plants in there. Just outside US, we also have a few where we can actually help you producing these products and to test the products to see how will it actually be with your raw materials that we actually have there. At the same time, we can go in and make like a performance agreement on the plant when it is that we have supplied, to be sure that it's still living up to the effectiveness as it is when it was a new plant that we were supplying to you. On the innovation center side, you can say we have in the US, we have plants where we can help you on developing these types of products. It is necessary to have this and in order to develop the new products, and we will be happy to help you on these type of on these processes. Life cycle is when we are supplying the plants, it is important that there's some service, we have support, that we actually can go in and do some help on these things, make a life cycle on the area. Also, if you have an older system, we can go in and help you on upgrading the plant and to support you on extending the lifetime of the plant that you actually have. Looking into these things, you can say this is the end of today's presentation. Now we will begin our questions and answer sessions. A quick note: after we complete this webinar, all participants will receive a copy of the presentation, and you are welcome to ask me a private question on these things. Encourage you to let us know what it is that you think of today and how we can actually help you on these things. And please give me a moment when I pull up the questions. I have a question regarding this, where we can go in and say that I was talking about InfusionPlus, and why is it actually that it is limited to ESL products and cold chain, and not as it is an aseptic product, and why can't we use it for ambient storage also? And you can say this is actually one of the key questions when we are talking about InfusionPlus, and it is actually a aseptic product. You can say that there is a lot of things that needs to be in place before we can create a product that is for ambient storage, ambient distribution. One of the things is the sterility. Well, that's easy. That's just a matter of temperature and holding time at sterilization temperature. But we also want to have a product that is stable, and we don't want to have a product where there will be some development of enzymatic activity into it. When it is that we have InfusionPlus, we will have high temperature short time, and that means that there will actually not be a big impact to the enzymatic activities that is actually in the product. So you will not destroy a lot of the enzymes, and not as many as you would actually do where you actually have on a tubular UHT or in standard infusion or an injection plant. You will destroy a lot more enzymatic activity in the product. So over time, there will be some faults to the product if it is that you have InfusionPlus and you have it under ambient storage. So that's the main reason for that is actually on a cold chain and that is a fresh product. You can see that there's actually where we can go in and say that the question number 2 is how many references do you have in US, in Americas? Well, you can say we have been building this system for many, many years, as I said. And you can say that it comes to hundreds. And exactly where it is, it's spread out all over Americas. A lot of them is infusion plants, some is InfusionPlus, others is injection, but then we also have a big pool of tubular and plate heat exchangers where we actually are doing these things. Globally, I think we have around 1,000 in reference business where we have installed base of around 1,000 that we actually have there. So you can say we have some experience in these things. The next question is like, why is there a difference between injection and infusion? You can say when it is that we are talking about injection and infusion, it is direct system. It means that it's heated up with steam. But the way that the heating is actually happening is that when you are having product running through a steam fill chamber, then it's just absorbing the steam and then being heated up in that way. And it means that we are designing the plants, the height of the fall to the temperature that we actually want to achieve with the capacity of the plant that is. Whereas with an injector, it's a little more complicated because you are injecting steam into a closed room, into a closed chamber where you want all the steam to be absorbed by the product. That absorption takes some time. How long time depends on the product that you actually have. So if you have a plant where you are actually manufacturing a lot of different products, it means that you have milk, for instance, pure white milk, and you're making this, the absorption time for the steam to heat up to the sterilization temperature will be 1. But at the same time, at the same plant, you are making other products with a higher viscosity or with a higher total solid, then the absorption time will be different. So we need to take the worst product that we can think of into consideration when it is that we do this. And that's the main difference that actually is between injection and infusion. Then there is a lot of other things also, but that's the main difference that actually is there. The next question is, what is the difference in runtime on a tubular UHT and a direct UHT? That is a little more difficult actually to answer, because there is a big difference in the runtime of the different products depending on the technology you have, but also on the recipe of the product that you're actually manufacturing. We can say that we have infusion systems running. We have some infusion systems that is running 220 hours in between each CAP. But we also have infusion systems that runs 8 hours in between each cleaning circle. So it is so product dependent on what is actually the runtime of the different products. In general, we can say that a tubular UHT runs shorter than a direct UHT. But the main reason for selecting a tubular UHT over a direct UHT is the cost of running with the plant. And you can say if it is that you make a calculation on these things, then the reduction of utility consumptions that you actually have on the tubular UHT versus a direct UHT will make up for the longer runtime that would be on the direct UHT. Then the next question is, for high fouling product, what is the best technology that you actually have in there? Well, you can say it's a little related to question number 4 on the runtime that we actually have on the different systems. We can say on high fouling products, it is very modern to make complicated products in the way that it actually is today and put them on UHT systems. Not all of these products is actually designed to be run on a UHT system. It means that they have not been designed to run long time on a UHT system. So there is a lot of proteins in it, and these proteins typically can be quite high fouling on these things. And when it is that we are doing this, a lot of the things that we are working with on improvements of the UHT systems is either to lower the costs of running with the system or extending the runtime that we have on these systems. And you can say one of the reasons why we're also working with extending the runtime is because of these more and more complicated products that is actually out there in the market that needs to be run on the UHT systems. But the best technology that is for high fouling products, that is without doubt, that is the infusion systems, especially because they don't touch any metal when it is that it's heating. because it's falling down into the steam fill chamber. So it's just absorbing the steam, and it's not giving any surface where it can actually start to be burnings on. It will start in the pump, and it will start in the holding tube, and then you have the flash chamber. But then we have been building some improvements to this, the seamless infusion, where we actually reduce the fouling that will happen on these high fouling products. But still, it is a challenge, and you need to have some specialty UHTs that's actually built for these high fouling products. Otherwise, there can be some challenges. Then there is a question from about the maintenance. What is the most expensive maintenance in percentage about infusion, injection, tubular, and plate? You can go in and say that if we look on a general maintenance and percentage on UHT systems, I have a rule of thumb just based on experience, and we say that a direct UHT infusion injection, that is somewhere between 5 to 8 to 10% of the invested value that is in yearly maintenance on it. The tubular is less, and also the plate heat exchanger is less. How much less depends a lot on how much is it actually run, you can say. The plate heat exchanger needs to have new gaskets every year. On a tubular UHT, it's very limited what there actually is of maintenance, but there is still some maintenance that needs to be done, and you still need to open it to check it, also for CIP and how it's actually the way that it is. So this will actually be the last words for me on this session. Thank you for your participation. It has been a pleasure, and I can see that we have been ongoing for nearly 55 minutes, and it was set to last for 60 minutes. So I will give you 5 minutes back to you and say thank you for your participation.